Previously, we've talked about the brief timeline for the development of our number sense. Since 2.5 million years ago, when human first emerged, to 35,000 years ago, human became aware of quantities. From then, it's not until 500 years ago, or AD 1600, when Arabic number system was adopted worldwide. But before that, there are many other number systems developed in different cultures. Roman number system is perhaps a famous example. There must be some significant disadvantages with Roman number system, right? Because otherwise, why people want to give up what they have been using for thousands of years and started learning a completely different number system? Our focus in this section is about some of the fatal drawbacks of the Roman number system. Whatever the number system is, whether it's Arabic or Roman or any other types, they're just about different ways to represent numbers. But what are numbers? We see physical stuffs out there, such as fruits, herds, or money. But do numbers really exist out there? If they do, then how come a lot of other animals don't see them? So numbers are neither purely physical nor purely imaginary, right? Numbers are abstract concepts created by humans, but they reflect our physical experiences about more or less. Then why humans only started appreciating different quantities about 35,000 years ago? And why your dog still unaware of quantities? About 30 to 70,000 years ago, cognitive revolution took place. The reason's quite unclear. Some scientists think it's due to some brain mutations. That's why I would consider it an evolution jackpot. The consequences were significant. For one thing, human was capable of imagining things that didn't exist physically, and the concept of quantities is one of them. The ability to think of things that haven't existed yet allowed humans to make more complicated plans. So they got better at tool making. They even started creating stories and myths that united more people together for larger scale collaboration. Collaboration means dividing jobs so that each individual performs a specific task. However, human collaboration is way different from the one in animal kingdom. The large-scale collaboration promoted more refined ways of dividing jobs. People realize that they have different resources and skill sets, so they work on producing different goods and services. An immediate product from such type of cooperation is you need to exchange goods and services, because everyone is working on only one thing. Their need can be satisfied only partially. In order to satisfy all your needs, you will have to trade goods and services with others. When you need to exchange stuff, having more or less will have immediate impacts, right? So you need to be able to count objects, to keep track of them, and then record them. Because otherwise, how would you know how many you have and also remember that? You can use anything to represent whatever you want. If I were a shepherd who needs to keep track of the number of sheep, I don't think that I would be smart enough to say, hey, let's create the symbols 1, 2, 3, and 4. Instead, I would try to draw sheep one by one onto a stone tablet and use it as my reference. Then around evening before going home, I would compare my physical sheep one by one to the reference picture. This way, I'm able to see if I have fewer or more sheep. Later on, I might find drawing each sheep very cumbersome, so I could use a bar instead to represent the quantity. These are called tally marks. Tally marks, in my opinion, is a very natural step humans took to record quantities, because this one-to-one mapping is relatively obvious. But drawing one-to-one mapping using tally marks became infeasible once the quantities become huge. That's why humans get rid of this one-to-one mapping by inventing more abstract ways. Let's see how Roman numerals handle this problem. The first three numbers are really similar to tally marks. But then number 5, they simplify the 5 bars using a brand new symbol V. Then they back out 4 by putting the 1 on the left, meaning a subtraction. Then they combine a 5 and a 1 to make a 6, another one to make 7, one more to make 8. You would think that you know where this is going, so a 10 would be 2v, right? But they don't like it either. They create a brand new symbol x representing 2, 5. Then they back out 9 by putting the 1 on the left. So the basic techniques Roman numerals use seem to be combining a bunch of symbols. People came up with a list of the basic symbols they have. Symbols for 1, 5, 10, 50, 100, 500, and 1,000. So let's try to make number 87. First you pick 150 here, an L, then 310, then 1 5, and 2 1. Here we go. Before we move on to talk about why Roman numerals suck, let's try to guess what they might dislike based on the fingerprints left. First of all, they really hate 5 1s together. That's why 5 1s become a 5, V. 510 becomes 50, an L. 5 100 become 500, a D. Then they dislike 2 5s together as well. So 2 5 becomes a 10, X. 250 becomes a 100, C. And 2 500 becomes a 1,000, M. So I think Romans don't really like tally marks. And I don't blame them. They are cumbersome, right? But somehow in between those basic symbols, for example, this 87 we just talked about, do you find that they are still very similar to tally marks?
Whoops.
Now we're ready to talk about why these suck. How do you make new symbols? For large numbers, seems that there's a new rule for that. You just put a bar over the symbol to represent 1,000 times of that. For example, C bar means 100,000. M bar means a million. Not too bad, right? What is 5 million? Shall we put 5 M bars together? And 10 million? 10 M bars? What about 50 million? Remember our suspicion about what they might dislike? Do you think they will allow all these M bars appended together? Even if they do, would you like it? Then what are they gonna do? They will have to create brand new symbols. Of course you can come up with new rules to tackle this problem. But the gold standard for a good number system is you need to have consistent rules and no confusions. Too many rules equals no rules. You can't change rules all the time, otherwise you will end up with mess. Romans worked so hard trying to get away from tally marks, but somehow they are caught in between the slot machine crunching random symbols for large numbers and making predictable symbols using tally marks way.
Oops.
We have these physical quantities, and we need symbols to represent them. The tally marks way is to produce a one-to-one mapping using bars. Romans create abstract symbols for large numbers. With larger and larger quantities, tally marks just keep appending more bars. Romans will create brand new symbols. For even larger quantities, tally marks seems very cumbersome. Romans has a mixture of methods. Sometimes they append the same symbol to represent larger quantities, but maybe because they also realize it's just too cumbersome. Once in a while, they decide to use a new symbol. Of course, consider what will happen if we have an ever larger quantity to represent. Because potentially there are an infinite number of quantities, right? The tally marks guy will need to have more stone tablets for sure. And Romans, they will need to have a meeting to decide. By keep appending bars, tally marks way is predictable, right? But very cumbersome. Being cumbersome makes it useless, because it will get overwhelming and nobody wants to deal with it. That's why Romans' way of creating brand new symbol becomes more convenient in terms of larger quantities, but quite unpredictable, since they don't have clear rules in terms of how to make new symbols. Symbol unpredictability has implication on computability for larger quantities. For example, what is 10 times 1 million? We know the answer is 10 million, but how are you going to represent this 10 million? By appending 10 M bars together? So how are you going to compute if there are no agreements on the symbols for the results yet? So the number system we need must be predictable and also convenient. Positional number system provides the solution. It only needs a few basic symbols, and then combine them through permutations. We are able to represent a large number of quantities. Our Arabic number system is one example. It's the gold standard in making symbols efficiently. It has consistent rules, no confusions, and totally computable. We're going to discuss it in the next few sections. We'll see how numbers are actually like names, and also how different they are. Then we will explore how positional number system helps us overcome our brain limitation, so that we can make sense of large quantities.